This is TWIS. This Week in Science, episode number 885, recorded on Wednesday, July 27th, 2022. How do AIs see the universe? Hey everyone, I'm Dr. Kiki, and tonight we will fill your head with AI, dead spiders, and shouting embryos. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer. Science is doing it. Whether it's scanning the sky in search of ancient galaxies and finding them, or seeking cures for cancers and HIV and creating them. Science is doing exactly what scientists imagined it one day would. When setting goals for exploration and discovery, science takes on the most difficult tasks and delivers again and again and again. Without science, we are but dreamers, poets in an impossible world, philosophers with a pocket full of insightful concepts, wishfully thinking, hopefully praying, blindly wandering from feckless thought to circumstances fraught with unexplainable outcomes, cobbling together incongruent ideas in place of rational understanding. But with science, we pull reality into focus, separate fact from fiction, bias from observation, and with clear-eyed purpose, get things done. And while the wishful cobblers of incoherent explanations still wander fraughtly boasting with blurry bluster, you have stumbled upon a place where dreams become reality. With This Week in Science, coming up next.
I've got the kind of mind I can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki Blair.
And a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We are back again, doing our weekly walk through the world of scientific wonders. And it's been a hot week. It's hot all over the place. All over the place. Hot in the science world as well. I have stories this week about zip codes for RNA, AI understandings, and death by lactose. What do you have, Justin?
I've got HIV cures.
Ooh.
Again. Just good news about wildfires.
Really?
NASA's new plan for Mars. And a bit of a rant about the fossil fuel industry.
Appropriate.
Always a good time for a bit of a rant. Yes, related to that topic. Blair, what is in the Animal Corner?
Well, tonight we have a very special edition of Blair's Animal Corner. I'm calling it Blair's Fetus Corner.
Okay.
It's a couple stories about fetuses. And then before that, we're going to talk about dead spiders and wildlife photography. And they're separate stories. It's not one thing. It's not people taking pictures of dead spiders, although I'm sure
I like that idea, though.
Oh, that could be a thing.
Oh, wait.
Sure.
Oh, there's one. Shoot, it's still alive. All right.
I can't take a picture of this spider.
No.
It's still living.
I find a dead one. Way I can get close enough.
Well, before we get to those mental pictures of dead spiders, I want to remind you that subscribing to TWIS, wherever it's found, is easy to do. You can find us on your favorite podcast platform. You can find us on YouTube, on Facebook, and Twitch, where we stream live weekly Wednesdays at 8 p.m. Pacific time. You can find us on KDVS 90.3 FM in Davis. I think that's Mondays from 8 to 9 in the morning. And you can also find us as TWIS Science on Instagram, on Twitch, and on Twitter. Basically, look for This Week in Science just about everywhere. You'll find us. Oh, yeah. If this is too much information, go to twist.org. That's our website, and that's where you can find all sorts of other great information about the show. But now it's time for the science.
Yes.
Okay. Have you ever wondered if when we are, talking about physics, or when you're in your physics class in college or even in high school, is this the only way that physics works? Do we really know that physics, the way we calculate it, the way that we look at it, the E equals mc squared, that the principles that led to the law of relativity, that if there are aliens with a different mathematical system or with a different way of looking at the universe, maybe they've come up with different physics.
Yes.
Have you
So
ever thought about that?
Yes.
I have a long answer, but I'll give you
Short
the
answer,
short one.
please. Yeah.
I give you the short one. The math could be different, but the results are different. That would be surprising.
It's the thing that always stuck with me was there were certain questions in physics that always were just like, we're gonna pretend it's like this, and that's close enough, and that always kind of got me. But especially the like, light is a particle and a wave, and sometimes it's one, and sometimes it's both, and sometimes it's, I was like, we're missing something. There's something that we're not looking at here.
Yeah, we still, are kind of like, what is gravity, right?
Yeah.
Is
Yep.
it a force? Is it a particle? Like, there's, what makes the force? We
Yeah.
still don't have answers for these things. Not that we can have to be expected to have all the answers all the time right now. Well, anyway, some researchers thinking about these questions and actually trying to think about, well, what if an alien were looking at the universe? How would they have come upon the various parameters that we use to define things? So in all of the aspects of physics, all the laws of thermodynamics, everything that we've come to codify as scientific laws, they are all based on measurable parameters. We have, you can measure a square, any kind of object. You can measure it by its height, its width, its length. We have forces like acceleration, velocity. We have all sorts of things that go together, but are they the right things always? So what they did is they used artificial intelligence that was basically given videos of different scenarios of fire in a fireplace, of very simple things like, well, not simple things, but springs bouncing up and down. Lots of videos of which the AI could make observations, and from those observations come up with parameters and then physics explanations.
Interesting.
And the AI came up with alternative physics.
Mm-hmm.
It came up with different numbers of parameters to explain things that we've come to explain. And they seem to have a certain amount of standardization. But I mean, this is by no means, like, oh yeah, AI sees the world differently. Well, it does see the world differently, but we don't know, we haven't falsified and made sure that all of their conclusions are really, really, really right. And the physicists, the roboticists who were involved in this, they're actually scratching their heads and going, what are we missing? What did AI see that we haven't seen?
Well, that's
Or
the
is
first
the
thing I
AI
thought of too, is constants. A lot of constants are just like, what number can I use that makes all of this make sense? Right?
But
Mhm.
part of the reason for the constants and the infills that later often get solved with mechanism and everything else is that we have observations. We start everything from observations, and we have many, many thousands of years of observations. The first thing I thought of when you were pointing this out was some ancient or old models of the solar system, where Mars would be heading one direction, then it would turn around and go the other way.
Right.
because it
What
was
can
all
explain
based
that?
on
Yeah.
the idea that the Earth was the center of our solar system. And what's incredible is those models worked. They were predictive.
Right. They're
With enough
predictive
observation,
with a
they
certain
could
amount
tell
of
you.
error.
Yeah, certainly. They can say, well, Mars is heading this direction. It's going to turn around and go the other way next month, right? And it would. Oh, okay. So we've got the right answer. Well, it wasn't the right answer. It was just a predictive model that was completely flawed in how it was conceiving these things interacting. But as a model in terms of predictive ability, still functioned okay.
Right. Well, this question, the question that these researchers are asking in their paper that was published in Nature, where did that go? Oh, that was way down there. Nature Computational Science this week, in case you're interested in checking it out. They're interested in the predictive aspects of artificial intelligence. How can artificial intelligence help make all of our predictions better? How can AI help us do better science? How can AI help us understand the universe more accurately? So they have been validating these systems with their AI models that have been, taught by video, so just observation, right? And uh, they determined they were able to validate the variables that were being used. They were able to validate the answers, but because there's more variables, basically these roboticists have come to the conclusion that they don't understand the mathematics that their AI is using, but that their AI is using mathematics that's slightly different. So this does suggest that maybe aliens have come up with different laws of physics that have different explanations. It does suggest that maybe there is something more to our universe that we aren't noticing, that we haven't accounted for. As brilliant as Newton and Einstein and all the others have been, it's once you start at a certain mathematical assumption and move forward, you're going to be using that same system. And maybe we're blinded by the system that we're using. And maybe we just don't have the right set of variables for a lot of things because we haven't defined them all because of our human interpretation of phenomena. Anyway, different ways to look at the universe. Very interesting.
Yes.
They're going to be looking at, they have a lot of things to continue this line of research on, but it's very interesting. So what more can the AI teach us about physics? All right, Justin.
Just a quick note on that too. The dozenal system, instead of a system of tens, if we had a numerical system of 12s, were the units that built up things. A third would be a finite number. It's a weird thing that we have a third is a 3.33 infinite number. A third of something is not infinite, but that's
it is a discrete amount. Yeah.
If it was a decimal system, it would be, you'd have to make up a couple digits, fit them in there. It would still look like 10 at the end, but there'd be 12 units. Hard to explain. Don't want to get into it. But you would have 4 would be a third of something. Mm-hmm. And it would just be fine. Nobody would have, it would be just there's nothing weird about that. But I remember having this awful time trying to conceive of why is a third of something infinite? And unending number as a kid. That bothered me.
Because our system isn't as accurate as maybe it could be. So, yeah, I find it fascinating, and it really gets at that idea of AI having not a human mind, right? That we aren't recreating human intelligence, especially for these kinds of situations that are very kind of specific. That the AI is a model that is going to create itself. Tell me about HIV, Justin.
Well, I don't really have much to say about HIV, other than researchers announced this week that a 4th person has been completely cured of HIV. And this is making it the 2nd person this year alone. This is a quote from the 66-year-old man who received the treatment. I am beyond grateful. When I was diagnosed with HIV in 1988, like many others, I thought it was a death sentence. I never thought I would would live to see the day that I no longer have HIV. And this individual was somebody who went on one of the trial drugs early on that ended up allowing him to live this long. One that most people who have HIV are now on these they're antiviral medications. So he was, but this came about not because he had HIV. He was diagnosed with leukemia in 2019 and was going to be receiving a bone marrow transplant. So they populated the bone marrow with stem cells from an unrelated donor with a rare mutation in which part of the CCR5 gene is missing, which makes people resistant to HIV. Bone marrow, of course, is where your blood is made, so it made more of that resistant blood and complete cure. High risk, though, of requiring a bone marrow transplant along with specific stem cell donation required makes the procedure a poor fit for the tens of millions of patients currently diagnosed with HIV. However, researchers are looking for ways to mimic the results of this extreme procedure without, of course, all of the risks. One of the things that was mentioned around this story was that in a bone marrow transplant, you essentially wipe out the immune system completely first.
Yeah.
And it might not work. And it's something that you would not undertake if somebody has a certain level of health and well-being and prospective future days ahead of them. But in this case, a patient has cancer, greater risk of dying in a short period of time, so go for it. Right? So now the search is on for less invasive form of gene therapy for the remaining 30 million people living with HIV.
Yeah, I would wonder if something like CAR T, where they take blood cells out of the body and use CRISPR or some other gene modification therapy to modify the blood cells and then put them back in, right?
And it's interesting because in the CAR T they actually use the ability of HIV to hide from the body, to train up the T cells that they're hybridizing and putting back in. So I don't know. I actually don't know if that CAR T therapy would work on somebody with
specifically,
HIV and antivirus.
But yeah. But doing something similar to the leukemia bone marrow transplant, but you can have maybe just blood cells or something, some other
one
way.
One of the ideas that got floated as science fiction in this, they said this is science fiction, but the idea would be to get to a point where somebody could get a shot with a CRISPRed enzyme that could go through and modify the bone marrow to produce what is an altered mutated gene that makes people immune to it. That it's still science fiction, but they're looking at all of the possibilities, and they know now that this gene this one gene difference is enough to prevent somebody from having HIV. Go into remission if you've already got it. Now they just have to figure out a way to get the cure to the source, the place where it needs to be. Integrate that gene into an already living person.
Amazing. Mm-hmm. All right, so we're curing HIV, and hopefully we will get many more people than 4, and there will be many, many more in the future. But let's move on from the living to the land of the dead. Blair?
I hope you're all ready for this. This is a study out of Rice University. This was all a hydraulics lab that found a dead spider on the floor. They were moving stuff around. It was curled up the edge of the hallway, and they were curious why spiders curl up after they die. And as those that are familiar with the anatomy of spiders will tell you, they have hydraulic muscles, essentially. They only have flexor muscles, which means that the hydraulics extend them outward. There's hydraulic pressure that does that. And so when they die, if they're not pushing out, the only thing that those legs are going to default into is curling in. So that's why they curl up when they die. So true roboticists said, we want to find a way to leverage that mechanism. So you guessed it, they figured out how to use spiders, dead spiders, as essentially a claw machine. So...
All right, please describe.
Yes.
How does this work?
So they repurposed deceased spiders as mechanical grippers. And so the two benefits there, it's natural, it's biodegradable, and it camouflages because it's a spider. So they have deemed this necrobotics. It's a new field of study that you should all keep an ear and an eye out for. This is a lab that specializes in soft robotic systems. They use plastics, metals, electronics. They use hydrogels and elastomers. They use chemical reactions, pneumatics, and light. They're even currently working on textiles and wearables. So they're trying to find ways to make robotics softer, more dynamic. And so, what a better thing to use than a dead spider, I suppose. So what they did is they found that there are internal valves in the spider's hydraulic chamber, or prosoma, which allows them to control each leg individually. So in the future, they're hoping they're going to be able to do that. But instead, all of those valves are open after they die. And so they were able to tap into that chamber with a needle. They attached it with a dab of super glue also to prevent any leaking of air. And then they had a syringe connected to the needle where they just put in a teeny tiny amount of air, and that opened up the legs like a claw machine. They ran one deceased spider through 1,000 open-close cycles to see how well their limbs would hold up, and they ended up doing pretty well. At about 1,000 uses, they started to break down. And so they think that has to do with dehydration in some way in the joints, and they think that they can actually overcome that, thank goodness, by applying polymeric coatings. So they think that they can really use spiders to do important manipulations. This is pick-and-place tasks is what they call them, repetitive tasks like sorting or moving objects on very small scales, like assembly of microelectronics. So they think, yes, Justin, yep, picking up a sponge there. So it really just looks like a claw machine. There's really no other way to describe it except it is a dead spider doing it. And they're able to pick up these little pieces of sponge, move them from point A to point B. And so they think that because they could camouflage, they could use this to capture smaller insects in nature. They can biodegrade them after they have used up their kind of uses. And that they can do soft manipulations like turning a light on or off on a switchboard. So it's, it's a thing that I guess we can do with science. We have figured this out. The real question is...
Ladies and gentlemen, present to you tonight a lecture on necrobotics from the esteemed professor of necrobotics, Dr. Frankenstein.
Yes, it's Frankenstein, please.
My favorite is spiders picking up spiders.
Yes,
so we
dead
can use dead spiders to clean up spiders.
Yes. A dead
what I
spider
love about this
being
story?
used to pick up another dead spider. You're correct.
You know what I love about this story?
Mm-hmm.
Is it any spider watching this video would be like, oh gosh, humans are horrific.
Yeah.
They're terrifying.
Hey, after this story, I gotta say, I agree.
They're more scared of us.
Yeah, so the thing that they were very interested in with these wolf spiders that they were using is that they can lift more than 130% of their own body weight. And they have found that based on the size of the wolf spiders, the smaller they are, the greater percentage of body weight they could carry. The larger they were, closer to just 100% of their body weight that they could carry. So they want to do further research. I'm so sorry, spiders. on smaller species so that they can test the limits of their ability to pick up things larger than themselves.
Oh,
So-
insects, you're in trouble now. Necrobotics, it's the hottest
yes.
field.
Yeah. Can we just can we have the normal science story where at the end of this I go, so with this information, we can make biodegradable microscopic claws with the same hydraulic mechanism. Why do we have to use dead spiders? Why?
Yeah.
So-
Use the same mechanism, make
Yeah.
little tiny biodegradable bots. Yes.
Right. But
Because
you
also,
start
let
with,
me just tell you.
You start with an observation in nature. You figure
Yes.
out how nature did it. You see,
Right.
is that the optimal? Chances are it's pretty close. And then you improve it from there. And then the next thing you know, you're using that claw based on that research to pick up core samples from Mars and
And that would
tiny
be great.
helicopters that you're putting onto rockets and sending back to Earth.
That's not how this research was presented, I will
No,
say.
but it
But
never
also
is.
here's the
It's
other
usually-
problem. No, it usually is. They usually say, and here's what we're gonna do with it.
No, they
But-
were like, we're going to use the dead spiders.
Yeah, because
Yeah.
this is the other
Yeah.
problem. This is the thing that, like, it's very easy to look right past. You can't use a long dead spider for a bunch of reasons. One being, if they died of natural causes, they might not have all their legs. Another being, if they dry out, the hydraulics won't work. So you need, like, a freshly dead spider, which, how do you get those?
You have a spider farm,
Yeah.
and then you, I don't know, do
Yeah.
you sacrifice the spiders for science?
Yes, I do believe in this case they froze them to euthanize
I
them.
think you're overlooking
So.
the constant need of spider prosthetics in the spider pet community,
Right.
and ignoring an entire segment of.
Sure. Yeah, so this is one of those, just because you could,
Doesn't
mean
mean you should.
you
I
should.
think they
Exactly.
should. I think they're doing good science.
It's
Sounds like-
very interesting. I just don't think spider claws are the solution. I think that this
Spider claw.
is
Spider claw.
it's a very interesting
Yeah.
test of, as you said, Justin, like natural design, like millions of years of evolution, and that is going to end in a very efficient and effective mechanism. But as generally speaking, dead spiders to assemble electron, I'm not interested.
Again, you
Thank
start
you.
with
right.
with understanding how to manipulate the
Yes.
dead spider, and then you create the non-organic version of it for your actual use.
Or organic, but synthetic organic.
Yes, but that is
which, so it's
they were
biodegradable.
focused on necrobotics, which is the point of this story,
Necrobotics.
and that is not that.
Moving on from spiders, let's talk about how things move around inside our cells. We know that there's a skeleton in our cytoplasm. There are little fibrils, tendrils that motor proteins, actin, myosin, move along, and they move things around. So you can have big proteins that get moved around, but little bits of stuff, RNA, that gets produced from the translation of DNA in the transcription of proteins. How do those little bits of RNA know where to go? Some of them have to stay in the nucleus. Others have to leave the nucleus to find a ribosome to be assembled into a protein. How do they figure out where to go? Well,
Glycolization?
not glycolization, but something very similar. There is, as published in the study in Nature Communications this week, researchers have determined that there are little tiny bits of code in RNA that is like a zip code. And these little tiny bits of code get read by little postal carriers, and the postal carriers say, you go here, you go there. And the postal carriers within the nucleus of the cell are responsible for this. So they first, these researchers determined that there were these little bits of code, these zip codes, that basically, if there was a certain zip code, all those same RNAs with that zip code went to a certain place. Different zip codes went to different places, and that's how the sorting, how the researchers saw the sorting. They were able to determine that there was this process going on. And so then they're like, okay, how does this really happen? And, there's little short segments, straight segments of RNA. There's also circular RNA. And they're like, is there any difference between these things? And they did find that with this linear and circular RNAs in the postal system, these postal clerks specialized in the different forms of RNA. So there's one postal clerk that likes the circulars and says, I'm going to send the circulars to where they need to go. And the other postal clerk only deals with the linear. So there is a categorization based on
package
shape
versus letter.
Yeah, exactly. And so they were able to determine that by blocking some of the activity of these postal clerks and blocking the ability of the clerks to read the zip codes, that the RNA totally got mixed up and didn't know where it was supposed to be. And so they broke the postal system in order to figure out how it worked.
That's incredible. So
Yeah.
my first reaction, of course, is anthropomorphizing a cellular. But then, when you think about it, the way any city operates and functions is so much just an upscaled version of what takes place in a cell anyway. In so many different ways that humans we didn't really invent concepts that we think we did in some places.
Yeah.
We've just reiterated what's taking place organically within life everywhere.
Yeah, this study also is groundbreaking because it uses a massively parallel RNA assay. They were able to investigate 8,000 genetic segments this way, and they were able to do it in days as opposed to weeks to months.
Wow.
So in the past, before the technology existed to allow this study to take place, it would have probably taken years to get through. They probably wouldn't have gotten to all of these genetic segments, the one at a time or two at a time or something. And now 8,000 at a time, which is just that's scaling up our ability to discover.
Yeah, and the tracking in time, location and time too. It's all very complicated.
Yeah. So there's a lot more to learn there, but there's a little RNA postal system in your cells that tells the RNA where to go. Do you have some good news for us today, Justin?
I absolutely do. This is just good news.
Blair is just shaking her head there. She's already frowning. Okay.
Fool me once, shame on me. Fool me 10 times, also shame on me. It's always shame on me if it's Justin.
Why? What are you doing that's so darn shameful is what I need to find out over there. Just good news. It's the science news segment that takes on the news you don't want to know about with the optimistic gusto of a one-legged spider on a high-wire act. Wildfire edition. Just good news. Researchers at the University of Nevada published a study in the Journal of Advances in Modeling the System. They found that our current large-scale wildfire seasons are only temporary, and that in future decades, wildfire occurrences and intensity will decrease. This is quoting from Aaron Hanan, a University of Nevada Reno researcher with the university's experiment station and an assistant professor in the College of Agriculture, Biotechnology, and Natural Resources. Boy, they put all of their departments under one roof. There are so many factors that we need to consider and better understand if we want to predict how the frequency, size, and intensity of wildfires will change over time. Our two studies that they published looked at how changes in temperature, rainfall, and atmospheric carbon dioxide may interact with the influence plant growth, turnover, and decomposition, and how those processes in turn affect fuel loading, fuel moisture, and different plant communities, which are two key factors driving wildfire regimes in the West. So the findings, wildfires drop in intensity, and that will come about thanks to global warming, which will reduce plant growth rates with extreme heat conditions and accelerate the decay of dead plant material, thus reducing fuel for future fires. According to the forecasting models, wildfires should increase in intensity for a bit during the transition, but in 50 years, that will change and rates will come down dramatically. So,
because everything will have already
good
burned.
news.
Yeah, I mean how long can everything burn if it's burned?
Yeah.
And if growth rates are reduced, then you don't have the regrowth.
Yeah,
And we can just stop managing these forests altogether.
They're just gonna
do their own
whole
thing.
global warming thing is just gonna burn itself out.
Totally.
Over the next 50 years.
It's like a toddler having a tantrum. You just gotta let them get it out.
Yeah. And if 50 years later, they'll finally be over it.
Okay, so what you're telling me is that as climate change progresses and the fires continue to add to climate change and the carbon dioxide that's being pushed into the air and the lack of those reservoirs, that's going to get worse. It'll go faster. So only a couple of decades. We just have to make it through like the next 15 or 20 years and then less
50
fires.
50 years they'll be increasing. After 50 years, the modeling.
Darn it. Okay, I was hoping just a couple of decades.
Well, but
And
no,
that's
that's good
assuming that
news.
the
'Cause
reduction-
50 years.
The reduction in
It's
plant
right around the
matter
corner.
doesn't make the CO2 levels spike even higher, that cause other problems that increase
Right.
the prevalence
The
of
feedback.
fire. That,
Yes.
there's other things involved.
Yeah.
Oh.
But with less plants, there'll be less wildfires. Don't you see? It's a self-sustaining system, after all.
Just fabulous. Just fabulous. What good news. Oh, Justin, what have you done? Blair,
Yes.
tell us
Talk
about
it.
your wildlife.
Oh, so the whole take only pictures, leave only footprints thing?
Yeah.
It's wildlife photography might actually impact the environment that you're taking pictures of. And that's, you're not physically leaving anything behind or taking anything away, but your presence could impact animals in the forest, as you might imagine. And so there have long been concerns from scientists about the proximity of humans, specifically to nesting sites of birds, and that might negatively impact bird reproduction. And so Guangxi University in China wanted to look into this in Nonggang, which is a limestone tropical forest region in southern China. And they wanted to see how bird photographers flocking to the area following the discovery of Nonggang babbler species there in 2008 impacted the nesting success of those birds. They were setting up their cameras close to the nests, and so that was giving them amazing photographs, but would that impact the birds? And scientists in general thought, for sure, it's going to impact their ability to feed effectively, and it's going to impact their success rate and survival rate overall. Surprise! Specifically, nest predation was something they wanted to look at because birds, mammals, and reptiles were killing about 60% up to 75% of the nestlings in these babblers. But in the 12 months that they looked, and looking at 277 bird nests, which covered 42 different species, they found that predation rates of nests that were photographed were 13.3%. Unphotographed nests had a predation rate of 62.9%.
Awesome. Humans finally did something good by accident.
Yes. So photographers increased the survival rate of bird nestlings
by disrupting predators.
So they had no effect at all, positive or negative, on their feeding rates, but they acted, quote, like a scarecrow and scared predators away. So
and our presence there probably lingers once we're gone. The scent of human in the area to a lot of predators.
And the sound around it, the whole time you're driving out, you're hiking out, you're setting up your equipment, you're tearing down your equipment, your sound and your impact can carry. So all of that can have an impact on whether predators feel like it's safe to go for out for dinner or not, But so the thing that I think is interesting is we're assuming right away that this is a good thing. Because predators are not eating baby birds.
We forgot it's a food web.
Right. And so I just wanted to bring that up because I didn't really see that mentioned in at least the press release for this study, that in some cases, animals that are endangered or have other undue pressure on them, reducing predation can help an endangered or a protected species. But if you're just looking at a species that's doing pretty fine amongst other species that are doing pretty fine, if you disrupt predation, you can mess up an entire ecosystem. What if the predator is a protected species, for example? So it sounds like a one-sided win-win scenario, but I just want to throw out there, not necessarily.
Yeah, talk about fool me once. You really pulled the rug out from under that. Humans didn't do a good thing after all. It seemed like we had a win.
Disrupting nature is, generally speaking, not good. So it's,
if you love
the
nature,
circle of life.
If you love nature, don't ever go anywhere near it.
It's just the question: Are humans the only wildlife appreciators on the planet? Are other, as we find out that more and more species are sentient in some way or another, and aware of their surroundings, how many go out and enjoy their ecosystem?
Yeah.
How many take a trip around, just checking out the neighbors? Looking pretty good today over there, Bob. Looking good. All right. Okay, moving on from photographers bad, maybe. Humans bad. We're not going to just talk about humans bad. Let's talk about how humans died thousands of years ago from disease and famine and drinking milk.
Oh, no, what?
Oh, yeah, I believe that.
So there's always been a question of what lactose tolerance has done for humanity. And only about a third of people on the planet have the gene to produce lactase, to break down the milk sugar in milks and not get gassy, awful tummies that cause a lot of discomfort.
That's an amazing. So I don't know anything about this. It's only a third of us who aren't weird?
The majority of people on the planet are intolerant to lactose.
Oh, man, I feel so much better.
Oh, gosh, I didn't realize
in Western culture, you would not know this. Because there's so much milk and cheese.
That just means 2/3 of people are walking around tooting a bunch.
Yep.
Without dairy, I don't know. I would have to find a different staple.
Well, there are different forms of dairy that have less lactose, but it's the, lactose from cattle specifically there's a lot. The lactose is strong with the cattle. Sheep and goats have lower lactose concentrations and so are a little bit better handled by people. But this is not the story. It's why did this gene begin to spread? And it had a very rapid spread for a while, for a few thousand years, and then it's just kind of around. We're not seeing over the last 2,000 years or so, we haven't continued to see this massive spread of tolerance to lactose. And why is that? Well, researchers at University of Bristol and University College London published in Nature their study of prehistoric patterns of milk use over the last 9,000 years. And the genetic aspects of that milk use mapped into historic events and things that could have been occurring historically. Excuse me. And so they were able to combine ancient DNA, radiocarbon, archaeological data, and use computer modeling to show that lactase persistence as a genetic trait was not common until around 1000 BC, nearly 4,000 years after it was first detected, and gosh, several thousand years after we had already started drinking milk, farming cattle, sheep, goats, and drinking their milk as a nutritional supplement. All right, so they are thinking lactase persistence got pushed to high frequency by some kind of turbocharging of natural selection. And so the researchers tried to figure out what that was, and looking at over 7,000 organic animal fat residues from 13,181 fragments of pottery from 554 archaeological sites dating from the earliest farming nearly 9,000 years ago, they were able to show that this persistence came about because even though milk drinking and use was widespread, for healthy humans, it doesn't really give a benefit to, I mean, you might have a little bit of discomfort, right? But if you're sick, what is happening in your colon is that the milk, the lactase that's in the colon, is drawing a whole bunch of water into your colon and can lead to diarrhea. And that, if you are already experiencing cholera, dysentery from other sources,
And we
famine.
know ancient humans were full of parasites.
Yeah, they're parasites. If you were, if it was like the Black Plague, or if it was, a famine, where if you were healthy and you had this lactase tolerance, it basically allowed you to be able to survive these periods more easily. You had less diarrhea. You digested your food better. So you were more likely to survive. So
you were less likely to be pushed out of the hut on a cold night because of your incessant flatulence.
Yeah. So the people who could not handle the lactose were more likely to die. So that led to a survival benefit. And so the natural selection of this variant was supercharged during this very unhealthy and dangerous time in our evolution. Yeah.
And yet somehow the weak managed to survive this and become the majority.
Yes. No, yes. But yeah, so we don't get sick as much. We don't have as much famine. And, depending on where milk is had, our medical institutions are better. Our practices are more sanitary. So it's overall a better world to live in. And so we don't really have this push for lactose digestion the way that we did in the past. So hence it's slowed down a bit. But yeah, human mortality drove this gene through our prehistory. Death by lactose. Any more stories for this first part of the show? No, we've done that. Okay. Well, it's time for us to move on then. This is This Week in Science. Thank you so much for joining us for this episode of our science podcast. We bring you the news every single week, and if you're enjoying the show, please share it with a friend today. All right, I have a very quick COVID update for us. You know how there's been a big debate as to the source of our current ongoing pandemic? Did it come from the Wuhan animal market? Did it come from a lab?
Yes.
Where did it come from?
Bats.
Bats, maybe. Yeah, right.
I say yes to all of it.
Huh.
There's
Sure,
been
why
evidence
not?
in many different directions. But a group of epidemiologists have published 2 studies this week in Science, looking at the epidemiology of the original outbreak, centering on Wuhan, China, and the fish market, or not fish market, the animal market it was a seafood market actually, centering on the seafood market, and additionally looking at how the cases spread over time, the different genetic variants that occurred, and they have come to the conclusion that the Huanan seafood wholesale market in Wuhan was the early epicenter of the COVID-19 epidemic. Their data does not support the idea that there was a lab breach. It does not support that it came from a lab. There are still many more questions to be had, but they have been able to dig into the data and see exactly how the spread seems to just come from and center around this seafood market. Additionally, at that market, they have determined that there were not 1, but 2 spillover events. So it's kind of like once there's a reservoir and the virus has gotten the ability to jump to humans, why would it just happen once? And so they have identified 2 slightly different genetic variants that were about a week apart in their spillover, but both at the Hunan seafood market.
Yeah, to my point of agreeing with all the sources, as long as somebody's believing that like, this is how bad it was, as long as somebody's believing that COVID exists, they could say it's from anywhere. I don't care. Interestingly, a lot of the people who were making the argument that it came from a lab also didn't believe it existed, which I found very, very interesting.
That raises a few eyebrows for sure.
Yeah.
Anybody can say
Incoherent.
anything, but that's not science, right? What we're doing is we're getting evidence to back up claims, not relying on pure speculation. And yeah, it takes time. It's not the kind of thing that is going to be answered overnight, especially when it's a very complex analysis. But it is I think the researchers who have worked on this should be very, very proud of the work that they've done and really kind of bringing this information not to a complete close, but a pretty satisfying and hopefully end of this discussion.
And it was the original suspect.
It was.
Yeah.
You got to check all the options, all the possibilities. Was it here? Was it there? Well, we've got different hypotheses. Let's test them. Let's see where the evidence goes and see what seems to be the strongest evidence. And that's where you stand. Natural. It's natural. It's all natural. Just like those breads and cookies and other things that you eat. Oh, and by the way, this week, the head of the World Health Organization, I'm seeing things ring similar to early stages of the pandemic for COVID-19. However, this is a different situation. The World Health Organization chief has declared monkeypox an international emergency. An expert panel hasn't been able to reach a consensus. The CDC is still having issues. We don't have enough vaccines. We aren't testing people. Doctors aren't doing what needs to be done. And monkeypox is beginning to spread more widely. Why did we not learn any lessons from the past? Our systems were obviously broken, and we don't seem to have repaired them. Again, things take time, I guess. Let's just hope that the monkeypox doesn't get us first.
I think with monkeypox, I see some things with it that make me very skeptical of governments and just generally people's response to it, just because of the way that it's talked about, the way that like they talk about it spreading through specific communities and through specific ways of transmitting, and that makes it feel very other to certain communities, often people in charge of making these decisions. So if you say that it's usually spread through sexual contact and that it currently is spreading in homosexual communities, then you put it in this category where it's not everyone's problem.
Yep.
And so I also
it's how we treated HIV.
Yes.
When HIV was an initial problem.
And this is a problem for everyone.
Yeah.
You don't have to be having sex to get monkeypox, and you don't have to be gay to get monkeypox. You can get it through touch with anyone for any reason at any time. So like this is not a specific problem for a specific set of people, but that is a convenient way to talk about it, because then it doesn't have to be quote unquote my problem to a lot of people making decisions.
Yeah, but I feel they're also like I don't know. Sometimes the stock market talks. There's the company that makes those vaccines, Bavarian something. I think it's a German company. When they first started talking about monkeypox, the stock jumped like 30%, and then they said, monkeypox is not a big deal. We don't have to worry about it, and it fell by half of its original value, and now it's like it's doubled again. So somebody's trying to react to this financially, and just watching that one stock, I've been sort of watching that as the ticker of how I've tracked that news, whether or not we were going to do something about monkeypox. But what's interesting is it doubled before this announcement. So even without the World Health Organization coming out and saying anything, a lot of money found its way there the week of this announcement before it was announced. So there's also like,
what's happening here?
Yeah.
Yeah. Well, I make sure to wipe down all surfaces in an airplane before I touch them with an antiseptic wipe. How am I going to touch this? Yes, I'm going to wipe it all down. So, there are practices we can do to all maintain our safety and to continue having normal. And monkeypox is not as big of a threat at this point as COVID-19 is or was.
Derek Schmidt is in the chat room. They're saying Health Canada talked about it being a homosexual issue.
Right, because that's where it has showed up initially in many communities around the world.
But it's not.
It's
the homosexuals, the only people who are hugging each other and having sex anywhere in this world? Is that insane? Insane the way. Although, if they're the only community that gets the health warnings, at least they got that going for them. But hey, we get the health warnings before anybody else does. At least that's nice, I guess.
This is This Week in Science. Thank you once again for joining us for this episode. If you love this show and love to support this show, thank you very much for helping us out on Patreon. If you haven't yet joined our Patreon community and would like to, you can become a supporter of TWIS by heading over to our website, twis.org, clicking on the Patreon button and heading over to our Patreon page where you can choose your level of support, $10 and more a month, and we'll thank you by name at the end of the show. We really can't do this without you. Thank you for your support. And now we will come back to that time in the show that's full of, I guess this week, embryos. Mm-hmm. Blair's Embryo Corner.
She loves our creatures, great and small. Biped, millipede, no pet at all. If you want to hear about animals, she's your girl. Except for giant pandas and squirrels. There's Animal Corner.
What you got, Blair?
I have have a story that I am very skeptical of, but I was fascinated by, and so I wanted to bring it for us to discuss. So first, I want to talk about the evolution of placental mammals. This is something that you are taught in, I would assume, high school biology these days. I don't know, but like if
Virus
you study,
infected us.
if you study biology, especially zoology, you're going to hear all about the evolution of mammals and how we came from an egg-laying thing. And first there were monotremes, which are egg-laying mammals. And then there were marsupials, who birth out undercooked animals. They're not an egg anymore, but they are definitely undercooked. They don't have all their legs, they're blind. They need to crawl through hair to continue cooking the rest of the way in a marsupium or a pouch. And then after that, we got the placenta. And with the placenta came the ability to grow big and strong and smart inside mom long enough to come out pretty well put together. And either you're ready to go, raring from the start like a giraffe or a horse, or you're set up to be real smart like apes, right? And so either way, cooking longer helps make this animal ready to go in one way or another when they come out of mom. So this is how it's always been talked about. This is the assumption based on the fossil record, based on all the information we have. But this week, University of Washington has new news for us. They found some evidence that they think tells us that another group of mammals, the extinct multituberculates, likely reproduced in a placental-like manner way before marsupials came onto the field.
What?
Yes. They split off from the rest of the mammalian lineage before placentals and marsupials, so they themselves, while they were contemporaries with marsupials and placental mammals, their common ancestor came before marsupials. Therefore, either this is convergent evolution to placental growth, or marsupials came after the placenta. Now, let me tell you how they came to this conclusion, because I also think this is important. How did they discover that these multituberculates were placental in their development? Because they didn't find a fossilized pregnant animal with a placenta in it that they could see in the fossil. That's impossible. So what they found was femurs, thigh bones. Stay with me. They obtained cross sections of 18 fossilized femurs from multituberculates. I'm not saying that right, but you get it. That lived approximately 66 million years ago in Montana. And all 18 samples showed the same structural organization, which was a layer of disorganized bones sandwiched between an inner and outer layer of organized bone. So you have your bone sandwich organized on top and bottom, a bunch of messy bone in the middle. Disorganized bone, or woven bone, is sometimes what it's called, indicates rapid growth. Under a microscope, the layers of bone tissue are laid out crisscross. In what is called organized bone, which reflects slower growth, the layers are parallel. So they examined femoral cross-sections taken from 35 small-bodied mammals that are living today, 28 placentals and 7 marsupials, and nearly all of the placental femurs showed the same sandwich organization, and the marsupial femurs consisted almost entirely of organized bone, with only a sliver of disorganization inside. So based on this femur, they think that these guys were placental in development. The idea is that for tiny marsupial newborns, the bones grow a lot more once they get inside the marsupium, the pouch. So they deposit a greater amount of outer organized bone before they exit to grow further in the pouch. So it looks organized internally because they have to use the bones way sooner. So based on this, they think that these multituberculates had a lactation period of approximately 30 days, similar to rodents, and therefore that they or placental. So if this is true, then you have over here, you have your multituberculates. Then over here, you have your marsupials and your placental mammals. And the marsupials and placental mammals are closer related than these new guys, which means there is a common ancestor way further back. And so either the placenta developed twice or this type of development, because I also am going to say we didn't see a placenta. We don't know there's a placenta. There could be something else going on here. There could be an entirely different fourth strategy for growing a fetus that we don't know about. But so whatever it is that they're doing, if a placenta is involved, it happened convergently. It happened twice, or that was the original organization and marsupials popped out later for another reason.
Yeah. Ooh, interesting.
Yeah.
So it's not as straight a path, not as cut and dried as we considered it. Interesting.
I like the second
interpretation.
That marsupials came later?
Yeah, that they developed a secondary strategy.
So the way it was explained to me in school that made it sound like so much sense. I'm going to see if I can not butcher this without a whiteboard. If I had a whiteboard, we could do a lot better. But so monotremes, they lay eggs. Part of the reason that they do that is that their embryo, their like blastocyst basically, is very smooth, and it can't really like gain purchase on the uterine wall properly. So there's not a lot of exchange between the growing monotreme and the mom. So it has to get out of there. It has to be self-contained and get out into an egg because mom cannot provide for it. A marsupial has like, it's like wrinkly kind of on the edge of the blastocyst. And so that allows for it to embed in the uterine wall temporarily, do some gas exchange. It gets what it can, but at a certain point, it can't grow any bigger with what it's getting from mom. And so it has to kick out to be able to grow further externally. In placental mammals, they develop a whole placenta. And the blastocyst before that is extremely wrinkly, has like fingers all over it properly. So it can embed in the uterine wall extremely well. It has really good blood and gas exchange. It can get nutrients from the placenta. And so it is good to go in there for a long time. And so based on that description, it sounds like the blastocyst is getting more and more complex. And if we think about moving towards complexity, that makes sense in a progression. So that story sounds great. But you're right, it's not always like that.
Well, now I want to reverse my answer.
Okay.
After your description, which totally makes sense, I would say that the marsupials must have originated earlier than we think. And that transformation that was taking place hit a point where it was just working and didn't need to go through that progression or that advance of that further complexity, because it hit a point where it had figured out how to make that work and stopped changing in that direction.
We do know also that sometimes traits are lost. So there is not always the progressive march toward complexity. We know that it's not always this
that
what looks like convergent or divergent.
We
can have things
that we talked
diverge.
The other argument for marsupials being more primitive is that they are prevalent on islands.
Yes.
And when the way evolution works, there's island biogeography and primitive traits or more kind of older and less advantageous traits are allowed to continue and persist because there's less selective pressure because they're on an island. So the fact that Australia is full of marsupials and there's not a lot elsewhere helps feed this theory as well. But without getting deeper into that.
But there are that example that was up there was like a North American opossum.
Yeah. There's one. Opossum. In North America, we have one marsupial.
But I mean, unless
on the island of North America.
Yeah. That opossum, doesn't look like the most travel hardy critter. It didn't look like it crossed an ocean. So we're talking it had to be marsupializing it territories back in Pangea type.
Yep.
I mean, that's a long time ago.
Certainly.
I mean.
Now, all of this got its start a very long time ago. Blair, let's keep talking about other embryos. Who else do you want to talk about?
I want to leave you with a nice image to go to sleep to, which is a baby marmoset silently screaming from within the womb. Good night, everyone. Even better, how about a human baby screaming silently from within the womb? You're welcome. So this is a study looking at baby marmosets and how it appears that they practice face and mouth movements necessary to call their family for help before they are born from within the womb. This may also apply to humans, as ultrasounds in the 3rd trimester of pregnancy have shown developing humans in the womb to make crying-like movements. So keep an ear out for future studies on that one. That just sounds terrifying to go in for your 3rd trimester ultrasound and to see your baby screaming. Anyway, moving on. So marmosets are a perfect example to look at this because they are an extremely social primate. They have to call their family members for help. They can do so within 24 hours of being born, and so it's really important for them to be able to do that. This is from the Department of Psychology and the Princeton Neuroscience Institute at Princeton University in New Jersey. And they conducted ultrasounds 2 to 3 times per week in 4 pregnant marmosets for a total of 14 to 17 ultrasound sessions per marmoset. It's a lot of teeny tiny jelly and teeny tiny ultrasound machines. Oh my god, so cute. Marmosets are really cute. You guys should Google it if you have not looked at a marmoset recently. Anyway, the face first became visible on an ultrasound, and immediately thereafter, they started seeing movements that they could measure. They did scans to longitudinally track the head, face, and mouth, and they compared them with newborn marmosets' movements when they called. In frame-by-frame analysis, they found that head and mouth movements coordinated initially, but the mouth movements became distinct over time, and eventually they became nearly indistinguishable from movements made by crying newborn marmosets separated briefly from their mothers within the first 24 hours after birth. Just to be sure, they also compared it to pre- and postnatal licking movements and movements associated with what they call twitters, which is another vocalization that is not a distress call. And these were, in fact, distinct and specific to calls that they made when they were separated from their mother. So this shows that they are practicing this behavior before they can even generate sound, because, they're in fluid and stuff. And these movements in marmosets may help scientists learn more about social vocalizations in other primates and their developments, including, of course, us. So they're practicing before they even come out.
Yeah. You gotta have practice.
Yeah.
Practice is important.
Certainly.
And why not start practicing before you have to, jump up on stage?
Mm-hmm.
This is This Week in Science. Justin, you're looking bright and happy and cheery on this Thursday morning.
The sun is
Yeah, what kind of
Thursday morning is well underway.
Yeah, what kind of science do you have for us for your section right now?
Last science story. So NASA has canceled the retriever robot that was supposed to go up there and collect all of those rock core samples.
No.
Yeah.
What?
Yeah, the ExoMars rover sidelined due to a war with Ukraine, with Russia. Between Russia and Ukraine. Russia was actually supposed to provide the rocket ride. It was a part of a joint mission, and European Space Agency and the U.S. and Russia were involved. And everybody cut ties. People are getting crazy. So they might still launch it. NASA's looking at it right now. I guess they put it into storage, mothballed it, and we'll decide later on this decade. They'll decide whether or not they can still launch it later this decade, sometime in the fall. They'll make a decision. However, NASA is going to go ahead and move ahead with a Plan B that they announced this week to retrieve the core samples from Mars with mini helicopters. Actually, that's Plan C. Under the new plan, NASA's Perseverance rover, already on Mars, making the course, needs to go and collect all those little droppings that it made, needs to pick up after itself, and take those to a rocket, which will then launch them off of the red planet a decade from now. Perseverance
but we still have
already...
to get a rocket there. This is adding to Perseverance's job, picking up after itself.
So the rocket that goes there was already part of a plan. That's how we're going to... Basically, Mars is going to attack Earth by firing rockets at the Earth filled with these little core samples. That was already part of the plan, but this EXO rover was supposed to be going up and collecting everything, going everywhere Perseverance had been and picking up the samples. There's 11 of them so far. And more rock drilling is planned. Actually, I think there's more than 11. I think that might be... Anyway, there's at least 11 lying on the surface of Mars right now.
Well,
there's
somebody's got to do the pickup work. That's great.
For NASA. Diversity of materials already in the bag, so to speak, and really excited about the potential for bringing these back. So if Perseverance gets stuck, if it breaks down, NASA's got the Plan C part of this, which is it's sending 2 helicopters, kind of like the little Ingenuity helicopter that's there already. Yeah. It's sending 2 helicopters that are going to launch later this decade to go and pick up those samples with something called necrobotic spider claw and carry them to the rockets.
Right, the necrobots created by Martian spiders. Yes.
Yeah.
Dead Martian.
But yeah,
spiders.
these choppers, new choppers, are going to have wheels and grappling arms.
Nice. Yeah.
Might as well bring some spiders. Why not?
Why not? Oh my goodness. Oh, NASA, yeah. Not American, but global political issues. It's good to have global partners, but it's a shame when things go awry. What?
Speaking of global partners. Okay, so here's the end of the show rant that I read about this thing in this article a couple places, and so I had to talk about it a little bit. So in the early 1980s, for those of you who weren't on the planet yet or just don't remember, the world was hearing warnings from the scientific community, not about global warming so much, but about a hole in the ozone layer. You remember this?
Oh, yeah.
Of course, yeah.
Ozone layer, the atmosphere. The ozone is this layer in the atmosphere that naturally protects Earthlings and all of Earth's inhabitants from the sun's harmful ultraviolet radiation. Without it, we could not live on the planet very long, or at least not on the surface. So dire was the warnings. Nations of Earth got together under something called the Montreal Protocol, and they all signed commitments to remove the ozone-depleting chemicals from industry and consumer goods, and it worked. Yeah, they got rid of the CFCs. The hole is still there. It grows and it shrinks from year to year, but it's considered contained at this point. No longer a looming, growing threat to human health or earthling existence.
Right, we've moved on to other ways of threatening our existence.
A decade later, the world heeded the warnings of science once again, took up the challenge of combating global warming by agreeing to cut carbon emissions under commitments made via the Kyoto Protocol. Different this time is at the same time that was taking place, the American Petroleum Institute, no doubt seeing what had happened to the CFC industry, I guess, and how quickly world governments acted to get rid of a dangerous, harmful pollutant. get rid of that threat, to minimize that threat, created a memo, which has been now called the Victory Memo, sent out a memo to its fossil fuel industry members, which support it, which is why it even exists, the American Petroleum Institute, which gets only donations from big oil companies, sent out a memo to its fossil fuel industry members laying out a plan to combat the public's perception of climate science. This report was eventually leaked to the New York Times a long time ago, and it is totally crazy. And I just felt like I read about it. I had not read this before. I think I'd heard, obviously that we've all heard that, they're conspiring with misinformation. That was obvious, that scientists were going forward who were oil industry backed, who were doing this global denying, especially in the earlier days. But I'd wasn't aware that this memo existed that listed how they were planning on going about it. There's a link to that memo on our website now in the show notes once the show is published. But the multi-million-dollar plan, which included dollar amounts, included also outreach to politicians, media organizations, and journalists. It stated that they would like to convince a national TV journalist, and this is no joke, they named a journalist in writing in the memo as an example of somebody they would like to have examine science behind the Kyoto Protocol. And they named John Stossel, who, as it happens,
the Stossel report. Yeah.
Went from being a consumer content journalist who was like, hey, watch out for this scam, to becoming a dedicated, single-minded climate change denier and minimizer in all of the years since. Even now, still doing it, getting banned from YouTube and Twitter and other places for misinformation, and still complaining about it, and still after receiving lifetime funding from oil industry sources. The guy who used to say, "Give me a break," finally got his big break as a shuckster. So but it's just so incredible. Reading this is the game plan. They lay out in the memo, creating a pipeline of information and this is also their words used in the memo, to undercut conventional wisdom on climate science by producing and distributing op-ed pieces to newspapers, by offering scientists of their own to go on shows and media to talk about climate science from their perspective. The plan stated it would develop and disseminate radio news releases nationwide. Disseminate radio news releases, because if you're the oil industry in America, you have ready access to put whatever message you like out as news on nationwide radio programs, apparently, because there's no line in there about needing to convince radio news sources or make contacts in radio news journalism. It was just a given that they could do it because, of course, nationwide radio in America is controlled by mostly one company. Even if you have 30 stations that you can tune into on your local radio, there's probably no more than 3 companies, if you don't count PBS, that control all of those stations. And they have a very conservative slant. So anyway, target audience of the oil industry remain largely misinformed to this day about scientific consensus and coming consequences. They specifically were targeting Republican audiences, not by accident, as this would easily led to the COVID misinformation after decades of devaluing scientific expertise on their information radio broadcast television systems. Meanwhile, global warming continues to produce hotter heat waves, wildfires, hairier hurricanes, severe storms, sea levels that won't stop till they reach the top. A Supreme Court ruling last month limited the federal government's ability to regulate carbon emissions from power plants. I didn't actually read that decision, but I assume it's because power plants don't have vaginas and therefore legally should not be the subject of government control. Point is, 1998, oil companies laid out an industry memo, a point-by-point strategy that they would use to influence a misinformation campaign, and then they followed through with it. How is this not a criminal act?
It's a great question.
Because we were watching a conspiracy theorist, or a couple of them. One who lied about some who were lying about voting machines, others who characterized this school shooting as a false flag operation. And they're facing financial consequences in defamation lawsuits right now. Where is that justice system reaction to an industry that intentionally lied about climate science for decades, while they knew from their own internal research that it was taking place man-made and fossil fuels were behind it?
It's because they themselves generated a system so that they could not be prosecuted within it. So basically, they have created an air of doubt and a situation where it is difficult for the average person or the average senator, I'll say, to point at specific tragedy and say, yes, that is climate change. And therefore, it is difficult to blame them for the results of climate change if you can't identify it. So basically, like, it's the idea that still that like climate change is far away and it's a big idea and we haven't seen the results of it yet. But we have. It's just people don't understand that we have. They see, the results of wildfires, or they see the results of pandemics, or they see the results of poverty. They don't understand that climate change is part of all of that. And so climate change has caused death, has caused hardship. That has happened. But
well, my
and it's
point
going
was
to get worse. It's going to get worse. But what's at issue here, though, is these were, they ostensibly the facts as they understood them. And so they are sharing their understanding of the climate science and preying on the media's need to share both sides of ism of media, making sure that they can get media attention. There are lots of aspects to this.
Question,
but
though,
it was all laid out.
Did the people who did this, did they really not understand?
No, they're greedy.
Right. Or did they think that they would be so rich that climate change couldn't reach them? Or did they not care about their own children?
I'm going to say all those things.
Yeah. So in my connecting in my earlier part of the story, in connecting the CFC ban and how quickly we responded after that, is I think what may have actually gotten so much of an concerted effort behind attacking the science behind global warming, because we got rid of CFCs. And the fossil fuel industry had seen that happen in the previous decade and thought, they might move on from us just as quickly. But my
whereas CFCs could be replaced with other chemicals that are harmful in different ways. Fossil fuels don't have an easy replacement.
Well,
so
they do. Actually, they do.
But in the minds of the fossil fuel industry, they're not going from fossil fuels to, look, we're doing solar. They're not doing that.
But also
or
CFCs, a lot of the ways CFCs were used was fairly novel. So it was also something that we can change our hairspray and our aerosols and all these things that have only been around for
those are some of the consumer goods, but in industry it was used quite a bit more for a lot of other purposes.
Right, but I don't think as long is my point. I don't think CFCs were around as long as petroleum has been around. And so it wasn't as ingrained into infrastructure, and there weren't as many lobbyists for CFCs. A lot of people that worked in CFCs could very easily pivot to other industries or replace it with a different, again, harmful chemical in another way.
but my point was about the need for the justice system or some legal action to take place. isn't so much about the damages that we know have been done to environment, economy, and health, which are huge.
Mm-hmm.
But if you look at those other lawsuits that are taking place against people who did disinformation knowingly or should have looked at a source without sources, defamed companies, defamed a horrible tragedy of children being called and called them crisis actors. This effort was a defamation of the scientific community. They were making claims over and over again, perpetuating them, generating op-eds, generating fake news stories that was defaming climate science, defaming from academic and institutionals all across the world. So I don't think you had in that case to show all of the damage they have done to make that case. You have a lie, you have knowledge that it's a lie, and you have an effort to perpetuate the lie. That's all.
And according to a March 15th article from Reuters, a federal appeals court on Tuesday rejected ExxonMobil Corp's effort to stop Massachusetts and New York from probing whether the oil company lied to investors and the public regarding what it knew about climate change. So there are legal probes underway, and at this point, there is there are things in process. It's decades later.
It's one of the few things where misrepresenting your company to your investors, maybe the only way you can get them is by giving money to people who profited from them. Great.
So for my last two stories, I'm going to move on to some lighter topics, brief and fun to end our tight 90. Ants. We love ants. Ants are cool. We know they have interesting pheromonal behaviors that allow for coordinated activities. And it's like, they're like acting like individual neurons or something. They're like acting like one big organism. Maybe they're these colonies, these hives, maybe they do have a hive mind, right? There are these analogies that we come up with when we're talking about these colony-based organisms. Well, researchers at Rockefeller University were looking into this group behavior of ants, and they have determined, based on mathematical modeling of behavior, of a specific behavior for ants dealing with a hot environment and when they choose to leave. So at a certain temperature, it gets too hot and they want to save their eggs. They need to save their little larvae and move away. And what is the cutoff for that? Is it always the same for every colony? How do they make this decision? They reported in the proceedings of the National Academy of Sciences that as temperatures rise, individual ants start to kind of make little changes to their behavior, but things kind of carry along generally for the colony as normal until all the ants as a group make a decision and decide to leave. They found that smaller colonies of just 30 to 40 ants would make that decision to leave at a lower temperature than a larger colony of ants, of a group of about 200 to 300 ants. So the smaller group decided 34 degrees Celsius was it. They had to go. The larger group, they maintained their colony up to 36 degrees Celsius, which is a bit hotter and can have physiological effects. Those 2 degrees can have differences. So what is it that allowed this decision-making sensory response to hit a different threshold? And they believe that it is group dynamics, and based on the behavior of the ants in their colonies, they determined that it's kind of like a neural net, that you can have one neuron having a little behavior, but You don't make a decision. So if one neuron on your brain is going beep, 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 I'm making noise, you should do something, you're not really, your brain as a whole, the network isn't making a decision and changing your behavior. But when a whole bunch of them start doing that, suddenly, oh, I have an idea. I need to do something and I need to change my behavior. So this neural net threshold comes about basically as a matter of probability, and that ants in a colony since they don't know how big the colony is, but altogether their behaviors influence the whole. And so it's all probability based, and they act like a neural net.
You sure it's not just counting the boats? And it's a small group, it's easy.
They're a little tiny. Oh, hey, Fred. Hey, James.
Yeah. Oh, we got to count all over again. Yeah, quit moving around. Put your antenna down if you're not voting. We're not voting yet. Ow.
Yeah. So they don't know exactly why a higher temperature is what's the threshold for the larger group of ants, but what they're thinking is that it could be that the larger the size of the colony, maybe the harder it is to get everybody on the same page and to relocate. Maybe there's just more larvae to deal with, more food stores. Like, it's just moving is hard when you have more people. Also, it's like herding cats.
It's like, how do they? Because somebody has to go and like build the new digs, right? Like, you can't just go. You got to find a new place. You got to build a new layer or labyrinth or whatever under ant hill thing.
But do the ants know that? The individual ant, maybe they don't know how big the colony is. Do they know how hard it's going to be? Why would that be a deciding factor? But anyway, it's these little individual activities that percolate up, create a higher probability of change, and at some threshold probability, change happens, just like in a neural net. And then my final story is coming back to the beginning of the show, artificial intelligence. How do artificial intelligences understand the universe? How we program them and what they learn? How can they learn the complexities of human language from our metaphors and our analogies, our fables, our stories? You can tell young children fables. Fables have meaning. They're often meant to teach about greed, or they have a lesson at the end. Don't steal the tarts. That's bad.
Yeah, in medieval times, there were lots of tarts going missing. That is true.
So anyway, this is not a peer-reviewed paper, but it was a presentation at a qualitative reasoning workshop with the International Joint Conference on Artificial Intelligence that took place this last week. And the researchers from USC were looking at understanding narratives through dimensions of analogy. And they tried to basically read fables to AIs that they had created to get this machine learning system to see if the machine learning system would understand commonalities and be able to recognize themes. So it's like I mentioned before, if there's several different fables, but all of them teaching lessons on the topic of greed, would an AI, a machine learning AI, be able to understand that greed is bad, that these all are about this topic of greed? Would they be able to pinpoint that? And the answer is no. No, they couldn't. The AI machine learning was not able to understand the human analogies. They were not able to understand these human concepts. They were not able to conceptualize what was in these fable-based stories. But what the researchers did say is that they actually learned a lot about humans and human understanding, because as they were going through the process of developing the materials to teach the AI, they found that the understanding of analogies very often is based on experience, and where one researcher would say, oh no, these two stories are alike. Another researcher might not have categorized them in that way. And so even among the humans who were trying to put together a study with which to train AI in this topic, the humans had discrepancies that and categories that were not so cut and dried. And so there's a lot, they think, there's a lot more there that we need to understand about the way that experience impacts our ability to understand metaphor, story, analogy, and how those differences vary from person to person. And so these nuances of human analogical reasoning need to be understood before we can start implementing them for AI technologies, for teaching AIs. How do we teach the AIs if we don't even understand ourselves?
Well, I think that's the trick, right? You have to find out what priming is necessary to understand a fable. If you just pump like Disney movies into an AI for a certain amount of time before that, then they'll understand right and wrong and good and bad, and then
important
maybe
water.
it'll work, right? Yes,
They'll understand water is something that a young woman contemplates before going on her journey.
Right.
Water?
It's a theme in like every Disney movie. Is that every princess has water that she stares at some point.
Oh gosh.
No, except for Little Mermaid.
That's funny.
Who stares
Well,
at
every Disney movie has has parents that die.
Yes.
So what is that teaching the AIs?
Yeah.
Dead parents and important.
But that's what I'm wondering, if like if pop culture and stories that we expose our children to as they grow up prime them for this because they have a sense of right and wrong and justice, right? Is that the theme that you need first to then understand the metaphors that exist in these other stories?
Yeah.
There has to be a level where suddenly the AI gets it. And I think that's where you'll start to understand like
the specifics.
What makes it work.
Yeah.
Yeah, what you do is you just got to feed it a steady diet of Mullah Nasrud and Sufi stories. And it'll come out at the other end very wise, but also very, very kind of snarky as well.
I want to
answer every
AI.
question with another question. Just like, truly wise humans are like the most annoying people to be around.
Why would you say that, Justin?
They never give you a straight answer. Because they're all
Who
about
has
teaching
answers
you to be wise.
anyway? I'm gonna try and play off being wise by just speaking in questions. And
why does that bother you, Justin?
Well, because I keep asking questions and I know there's, see, you're doing it to me again. They always fool me. I start to try to find out something and then they try to get me to introspect about a thing. And it's I don't have time for that. I just want the answers to everything.
Well, we had a few answers today. We had a lot more questions. And I do hope that you enjoyed this episode of TWIS once again. We've made it to the end, have we not?
We have.
I think we have.
Yeah. Well, thank you, everyone, for joining us for another episode of This Week in Science. It is time for us to say a few thank yous to specific individuals. Many shout outs to Fada for help with social media and descriptions over on YouTube, show notes, Gord for manning the chat room, Identity 4 for recording the show, and Rachel for your wonderful editing and assistance. And I would love to thank our Patreon sponsors for all of their support that allows this show to keep going. Thank you to Teresa Smith, James Schaefer, Richard Badge, Kent Northcote, Rick Loveman, Pierre Velazarb, Ralphie Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody MS, Chris Wozniak, Dave Bunn, Vegard Shefstad, Hal Snyder, Donathan Stiles, a.k.a. Don Stylo, John Lee, Ali Coffin, Gaurav Sharma, Ragan, Derek Schmidt, Don Mundis, Stephen Albaran, Daryl Myshak, Stu Pollock, Andrew Swanson, Fredis 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles, Jack, Brian Carrington, Matt Bass, Vote Beto for Texas, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, a.k.a. Zima, Ken Hayes, Howard Tan, Christopher Rabin, Brendan Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Chemi Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Rudy Garcia, Dave Wilkinson, Ronnie Lewis, Paul, Philip Shane, Kurt Larson, Craig Landon, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, and Jason Roberts. Thank you for all of your support on Patreon. And if you would like to support us on Patreon, head over to twist.org and click on that Patreon link. On next week's show,
we will be back Wednesday, 8 p.m. Pacific Time, broadcasting live from our YouTube and Facebook channels and from twist.org/live.
Want to listen to us as a podcast? Maybe while you clean up all the dead spiders around your home? Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe as well.
For more information on anything you've heard here today, links to the stories and maybe even some show notes will be available via our website, www.twist.org. And you can even sign up for the newsletter that Blair's about to send out, I believe.
Yeah, after Justin writes some content for it, for sure. You can also contact us directly. Email Kirsten at KirstenThisWeekinScience.com, Justin at twistopinion@gmail.com, or me, Blair, at blairbaz@twist.org. Just be sure to put TWIS, TWIS, in the subject line, or as you might have guessed, your email will be picked up by a dead spider and dropped into a bin where we will never read it.
Oh, no. You can also hit us up on the Twitter where we are at Twist Science, at Dr. Kiki, and at Jacksonfly. Oh, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth. And I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.